Hi everyone, this is Miss McConnell,
And Mr. Huff.
and this is your video as promised with a couple example problems of simplifying trigonometric expressions. The one thing that I really want to remind you of as I work through these problems is that there are so many different ways to do these problems, and you might take different steps from us. So I want you to take my steps with a grain of salt. I don't want you to think like, oh, I did it wrong because I didn't do the same steps. In fact, the other thing to remember is that you won't always take a productive path. In fact, in part C, I'll go ahead and show you an example of a path that I ended up taking that was so annoyingly unproductive. I got there in the end, but it took me so many steps and I didn't see something that actually ended up being really obvious. So just keep in mind that you really do have to work through these problems to start noticing those patterns.
And just be aware that when you are solving and trying to simplify these expressions and you take an unproductive path, don't be afraid to just, try and grind it out as long as you can. But if you're like, this is getting me nowhere, put a line through it, start over and see if you can't take a different approach. Don't spend a whole lot of time on it if you feel like it's going to be an unproductive struggle. Pause and move on to a different style, or see if you can't notice something different.
Try a different way, try a different path. And definitely don't erase, because sometimes that old work actually does end up being useful and you'll be really kicking yourself if you erase your work.
Mm-hmm.
So one of the things that you always want to remember with this that might be useful is I always start with the fundamental Pythagorean identity and I write it out. And then from that, in my head, I have this inner dialogue. Yours might not be inner yet, by the way. And I write out all three of the Pythagorean identities by mentally dividing everything by cosine squared x for one of them, and then mentally dividing everything by sine squared x for the other. Now, I do that mentally. That's my inner dialogue. You may have to write it out a couple times before it makes sense to you. So dividing by sine squared of x, I get 1 plus cosine squared x over sine of x is cotangent squared x equals 1 over sine squared is cosecant squared of x. And then I'm going to do the same thing with cosine. So I'm dividing everything in my equation by cosine and I get tangent squared x plus 1 equals secant squared x. And I'm not showing you that process because we already did that in class.
Mm-hmm.
So you'll notice really simple ones like a secant squared x minus 1. One way to do this is to simply replace secant squared of x with what it is equivalent to. Another way is to manipulate this equation directly. So for example, I notice that I can subtract 1 from both sides and I'll get secant squared x minus 1. And that directly gives me the same expression, that substitution. Mm-hmm. And so I know that this one's going to be tan squared x. Mm-hmm. In part B, I'm going to do that one definitely, because you'll notice that those are the conjugates that come up so frequently. And so the conjugates are really important. So I'll go ahead and pass that off to Mr. Huff. Sure.
Yeah, so I was talking with a student in, I don't remember if it was the first hour or my next class. Actually, it was in your class in the first hour. And they said, well, there's no cosine squared, or there's cosines here, but there's no cosine squared. But they did know that if it's a Pythagorean identity, we do have a cosine squared in the fundamental one. And so their thought was, well, I'm just going to multiply and see what I get from it. The nice thing is that this is a conjugate. And so when we multiply these things together, some stuff in the middle will add up to 0, and we can get that to go away. So 1 times 1 is 1. 1 times this is negative cosine of x plus cosine of x minus cosine squared. These two pieces here add up to 0. Like I said, some stuff in the middle will add up and add to 0 and go away. And so we get left with 1 minus cosine squared of x. hopefully if you see a 1 and a cosine squared, hopefully your mind, especially when you're simplifying, jumps to thinking Pythagorean identity or substitution of trig identities of some sort. Notice that this is written as 1 minus, so you have 1 is equal to all this, so you can substitute this whole section in if you'd like, or like in the first one you can rearrange some of these pieces and so that you can get 1 minus cosine squared by simply subtracting cosine squared x on both sides. And then you would get sine squared x is equal to 1 minus cosine squared x, and so this is then sine squared x.
So I'm going to show you an unproductive way. I'm not going to show you the productive way for C, but because I had just done the complex conjugates aspect of part B, I was thinking to myself, I'm going to go ahead and distribute for part C.
Multiplying seems to
so
work well.
I went ahead and distributed, and I ended up getting 1 plus tangent squared x minus sine squared x minus sine squared x tan squared x. And then what I started doing was replacing things with identities. So I saw, oh, hey, there's 1 plus tangent squared x, so let me just replace it with secant squared x. I went ahead and thought, secant squared x minus sine squared x minus sine squared x tan squared x. I was like, I don't see an identity here. I'm not seeing that. So then I saw a common factor between those two terms. And then I said, okay, well, I don't know where I'm going, but I'm just going to go ahead and factor out that sine squared x from both of these. So that leaves me with 1 plus tangent squared x. And then I was like, oh, there's an identity again. So I got secant squared x minus sine squared x secant squared x. Then I went and factored out secant squared x. So you can see how much more complicated.
Yeah, you went the long way.
I made that problem. And let me tell you that my mistake that I made there was not stopping to analyze the problem at each step. I just kind of started doing algebra. And I think it's really important to honor this process. You might see us make videos of these perfect processes, but that wasn't necessarily our first step. So I just wanted to show you an unproductive way that I started with. I'm going to leave it to you to find a more productive way. Well, what I did for myself was once I saw this, I just was like, oh, face palm. I'm going to put a line through this and I'm going to do it a more productive way. I started seeing that more productive way. Mm-hmm. In number 6, again, those strategies of looking for your Pythagorean identities is something that is really consistent with trigonometric expressions, with simplifying them. And so when you work with these fractions, you're looking for how can I manipulate this in a way that will get me these. So instead of actually doing a lot of these problems, I will tell you that, for example, in part B, I am going to start multiplying by giant ones that give me the conjugate so that I have those middle terms making 0. I'm going to be looking for things, for example, I see that this is a difference of 2 squares. Therefore, the idea of the complex conjugates might be helpful there. So we will do one of these for you. But again, we're really going to leave it to you to make sure that you're working through these. So I will let Mr. Huff take this next one. Before I pass it off to him to show you a way that is productive, I just want to again emphasize that we took super unproductive paths at first. What you're getting out of this video is not going to be nearly as much as you would get if you work with peers, because then you'll see those multiple ways of doing it and be able to try things together.
Yeah, and that was a picture of my terrible work.
But it's not terrible, because the thing is that he got started and he tried something, and that's the thing you have to remember about these.
Okay, so a productive path. Let's see. I'm gonna I don't want pink. We're gonna start by multiplying by the conjugate of 1 plus cosine of A, since 1 plus cosine A times 1 minus cosine A will give us 1 minus cosine squared, and we can do some substitution with that. I'm just going to kind of ignore this right now. I'm going to keep writing it with everything, but I'm only going to be working on this this side, as to not like introduce too many new changes. So I get 1 plus cosine of A over sine of A. And then I don't typically multiply stuff together in the beginning because I really want to see if something's going to divide. So I leave it just in a factored form. And when I multiply these together, I get 1 minus cosine squared of A. 1 minus cosine squared of A is sine squared of A. So I have 1 plus cosine of A over sine of A plus sine of 1 minus cosine of A over sine squared of A. Now it helps me notice my common denominator. I just need to multiply this side by a form of 1, that is sine over sine. Once I do that, I get sine squared in the denominator, so then I have sine of 1 plus cosine of A plus sine times 1 minus cosine of A, all divided by sine squared of A. From here, I notice that I can factor out a sine. Oh, I should have did sine of A on this. Forgive my sloppy notation. What? That's not where I put the cursor. One plus.
Just so you all know, Mr. Huff is left-handed and my screen is for right-handed, which is why he is struggling. So if you're noticing a little bit of struggle, bear with us, be patient.
The cursor moves it a little to the left, and so where I think the pen is going to go, it doesn't always go. So if I factor out a sine, I'm just going to bleed into this.
That's fine.
So I'm going to just factor out a sine. Sine of 1 plus cosine
sine of A times.
What did I say? Sine of?
Mm-hmm.
Sorry. Sine of A times 1 minus or 1 plus cosine of A plus 1 minus cosine of A, all divided by sine of A. Nicely, or sine squared of A. One of these will divide. I'm going to just expand this sine squared so that we see that a little easier. Sine of A times sine of A. And one of these will divide.
And the reason that it divides is because you have a factor and another factor.
Yeah, we have a single term right now in the numerator.
Do not get confused by you have the reason that you can do that division is because you are multiplying two things and this is also a factor. So remember that you can't do that if you're adding terms.
Mm-hmm. And so if we were to add this stuff up, this cosine of A and this negative cosine of A add to 0, and so we have 1 plus 1, which is 2, divided by sine of A, which is equal to 2 cosecant of A.
Because 1 over sine of A equals cosecant. So you can kind of visualize that as 2 times 1 over sine of A. And that's how you get the cosecant of A. So we are going to stop this video here and then we'll do a quick example from number 7 as well. But again, we want to reiterate, these are like puzzles and you don't always see the right way right away. So you'll need to play around with these. You need to work with peers. My bet is that all of your peers are actually going to do these differently. So I'm going to keep reiterating that because it's so important.
And just know it took me probably about 10 or 15 minutes just to figure out this particular method.
Right. We still have to figure out the puzzle sometimes, and we have some strategies. So you can look up strategies online for simplifying trigonometric expressions, but we recommend actually starting to develop your own just by playing around with them several times over and working with peers and seeing how they approach it.